Hello everyone, it's incredible to be here with our developer community. Today, I'm here to tell you about the next evolution of PICO. To understand where we are going, let's go back to where we started. PICO was born in 2015. Over the last decade, we have launched 10 XR headsets and 5 major OS generations. We brought millions of people around the world into XR. And now, we are showing you the blueprint for the next chapter. We have spent the past 2 years crafting the future. We built a system that unites 2D, 3D, virtual and real into one seamless flow. This is PICO OS 6, an XR operating system designed for the future. And today, we are giving you the first look. PICO OS 6 is built on 3 core principles: efficiency, intuition, and openness. Let's start with efficiency. Efficiency is at the center of how we use a computer, and a highly efficient computer requires a robust multitasking design. On a PC or tablet, multitasking is a solved problem. But in XR, the old approach simply doesn't work. Here, the challenge is significantly greater. An XR OS must render 2D apps, 3D objects, virtual environment, and physical reality all simultaneously. Multiple 3D apps must coexist while staying perfectly responsive. We realized that to solve this, we needed something new. We spent the last 2 years building a core engine with a unified rendering architecture. We called it PICO Spatial Engine. It fundamentally changes how graphics are processed. It moved the rendering pipeline from the app level to the OS level. The OS now acts as a conductor, controlling the rendering of all the pixels. It can dynamically allocate CPU and GPU resources in real time, ensuring that multiple 3D apps as well as 2D apps can run in harmony. The result is true spatial multitasking. In PICO OS 6, you can play a 3D tabletop game with friends present as 3D avatars, while your browser and other 2D apps remain open and active, floating above your real desk. This coexistence of 2D and 3D, virtual and real, is only possible with a unified rendering architecture. Next is intuition. PICO OS 6 makes interaction natural and intuitive. We design an input system that adapts to you. You can navigate with your eyes and hands, simply look and pinch. For XR gaming and 3D creativity, just grab your PICO controllers or motion trackers. And for productivity, your mouse and keyboard feel perfectly at home. An intuitive OS should also have aesthetics. With the PICO Spatial Engine, we are introducing a new design language for PICO OS 6, Cloud Crystal. This new design features a sophisticated, vibrant UI texture that merges with the real world. It feels weightless, yet substantial. It's solid enough to hold your content, yet open enough to let your environment breathe through. As the light in your room changes, the UI dynamically adapts, matching the ambience of the space. We also deliver a massive leap in readability, ensuring that text and other visual elements remain crisp and detailed at all times. Now, let's talk about openness. We approach this new generation of OS with a mindset of openness. PICO OS 6 is designed to support a wide range of app ecosystems: spatial, OpenXR, WebXR, Android, and PC VR. We are also deeply committed to our existing app library. Your favorite VR games from previous PICO products are fully compatible and will perform even better on the new system. We view all this ecosystem as equal pillars of our platforms. We believe openness is what XR truly needs. It is the only path that serves developers. And now, to show you exactly what's possible to build as a developer for PICO OS 6, please welcome Jinke.
Thank you, Jesse. Hi, everyone. You've just seen our vision for our general spatial operating system. With PICO OS 6, our focus for developers is to advance that vision by enabling you to build immersive experiences and multi-app experiences. First, for native spatial app developers, you can start with the new PICO Spatial UI. We designed this system to take the heavy lifting off your hands, abstracting spatial interfaces into component-based APIs. We also provide design guidelines, Figma assets, and a component library with consistent themes. So you can focus on creativity, not complexity, and build intuitive, polished interfaces. Powered by the PICO Spatial Engine, all the UI elements adapt uniformly to lighting and material variations at runtime. This ensures clear, stable interfaces across both bright and low-light environments, reducing the cost for environment-specific UI tuning. Under the hood of the front-end UI, the PICO Spatial Engine handles the complexity of the shared space at the system level. For example, it will intelligently address real-time occlusion, text clarity, and multi-modal interaction. So you don't need to write a single line of code to solve them. In addition, PICO Spatial Engine features lifelike spatial audio, natural physics, and dynamic graphics such as particles and lighting. These capabilities are woven into the OS, providing a solid foundation for building spatial apps. Beyond visuals and interaction, PICO Spatial Engine delivers core MR capabilities, including scene understanding, semantic labeling, mention, plan detection, and persistent spatial anchoring. This enables developers to create content that stays stable and tightly aligned with the user's environment. The engine provides a comprehensive set of features for building spatial apps, and it's built on a modern ECS architecture, enabling long-term extensibility. And all of these capabilities are available through the new PICO Spatial SDK. The SDK uses Kotlin and a declarative UI framework that developers are familiar with. To make development even easier, we introduced PICO Spatial Plugin and PICO Spatial Editor, letting you do everything inside Android Studio. For existing Android apps, PICO Spatial Engine supports them out of the box. And when you are ready to make them spatial, our SDK and toolchain keep the migration effort minimal. Now, let's look at how web developers can bring the web to spatial. What if building spatial apps was as easy as building websites? Today, we are introducing Web Spatial, an open-source framework that brings the power of the web into spatial computing. Web Spatial lets you use the tools you already love, HTML, CSS, and React, to build spatial web apps. It's lightweight and fast. With just a few lines of code, you can spatialize windows, anchor content, and create native-feeling XR apps right in your browser. Web Spatial is an open-source, evolving framework, not limited to PICO, but designed to build an open ecosystem for all web developers. It can run everywhere, on PC, mobile, and across spatial computing platforms including PICO OS, Vision OS, Android XR, and more. Last, for game developers, PICO OS 6 continues to support your workflows with our game engine SDKs, including Unity, Unreal, and OpenXR. With PICO Spatial support for Unity Unreal, you can now build MR games that live alongside everything else, so players can game, watch videos, and chat with friends at the same time. This is an entirely new style of gaming. It's closer to desktop gaming with multiple windows, social, flexible, like your everyday entertainment. So, whether you use native web or game engines, the boundaries are no more. With PICO OS 6, we aren't just giving you new tools, we are giving you a new world to build. We look forward to having you in our open developer community. Now, I'll hand it back to Jesse to tell you more.
This is PICO OS 6. It starts with PICO Spatial Engine, a unified rendering architecture. It delivers spatial multitasking, environment understanding, and natural interaction. And for developers, we offer not just intuitive tools, but full support for a vast app ecosystem. You can build with the code that you are already familiar with. The best part is, you don't even have to wait. All these tools are available starting today. And with the new PICO emulator, you don't even need a headset to get started. You can build, test, and iterate directly on your PC or Mac. Everything's live right now at developer.picoxr.com. We invite you to download the tools and start building today. Now, we have shown you the new operating system, but today's announcement would not be complete without the final piece of the puzzle. So, lastly, we want to share an early preview of the hardware that brings our vision to life. For the past 3 years, we have been engineering a new flagship device. Internally, we call it Project Swan. The goal of Project Swan is to break through the core technical bottlenecks of XR. Today, let's talk about 2 of them. The first is clarity. If this device is going to replace your monitor, you need to see text perfectly. That requires the PPD, or pixel per degree, of at least 40. For context, previous generation headsets were below 20. To solve this, we customized a new generation of micro OLED display. Our goal was to achieve 4000 ppi. This is roughly 9 times the pixel density of the latest smartphones. Combined with our custom optical design, Project Swan has an average PPD of 40, with the center sweet spot exceeding 45. This delivers the critical threshold of clarity needed to make Swan a viable alternative to physical monitors. The second breakthrough is in mixed reality. Reproducing mixed reality scene in a headset involves a massive pipeline. The signal has to travel a long journey, starting from the sensors capturing the scene, to the pipeline where virtual objects are added, and finally through the displays into the human eyes. At every step, we must meet the rigorous demands of human visual system. Standard software and hardware solutions simply cannot keep up. So, in 2022, we committed to designing our own custom silicon. We built an XR chip specifically for mixed reality. This chip integrates multiple in-house designed computing units. Through the chip-level perception and imaging engine, we can fuse data from multiple sensors with ultra-low latency, constructing a realistic representation of the physical world. This enables ultra-high-quality see-through, precise positioning, and stable eye and hand tracking. It drives the entire system's end-to-end latency down to just 12 milliseconds. This is the difference between looking at a screen and feeling like it is real. And to achieve the ultimate experience, we also need some raw powers. This brings us to our unique dual-chip design. Alongside our custom XR chip, Project Swan also features a flagship SoC. The performance leap over today's XR2 Gen 2 is significant. We are looking at more than double the CPU and GPU performance. Together, the custom XR chip and the flagship SoC drive dual 4K visuals with unparalleled clarity. When you combine all these hardware innovations with the spatial architecture of PICO OS 6, the result is definitive. Project Swan is our most advanced flagship, designed for those who demand the absolute best. Today is just a glimpse. Project Swan is packed with many more technical breakthroughs that we are eager to share, but we are saving the full review for the official launch. We are currently in the final stage of bringing this product to you, and we are targeting a global launch in 2026. If you would like to experience Project Swan and PICO OS 6 early on, we have an exciting news for you. We are launching the Global Early Access Program. We are looking for a select few with deep expertise across XR platforms to join a closed beta test. We want your rigorous feedback to push Project Swan to its limit before it hits the market. If you are ready to help us define the next generation of XR, you can apply for the Early Access Program right now at picoxr.com. Thank you very much for joining us today, and we will see you later this year.